Symbolic planners have a long history solving complex problems via formal logic. What would happen if we paired them with the reasoning power and adaptability of large language models? Using symbolic planners delivers efficiency and cost benefits between 100 and 1,000 times greater than relying on reasoning alone, plus a noticeable boost in performance for state-of-the-art prompt engineering techniques. In this video, we'll explore how symbolic planners, with their long-standing tradition in solving complex problems, can be integrated with large language models. We'll break down how these planners work, how they can be combined with LLMs, and what are some of the most exciting applications in the industry. By the end of the video, you'll see how this integration could become the future of planning and complex problem solving in AI. Hi, I'm Santiago, and I explore big ideas in AI. Today, we'll be seeing a neuro-symbolic architecture, LLM for LLM planning. So this is a paper by the researchers in the University of Edinburgh from the School of Informatics that propose dynamic planning to combine the traditional capabilities of symbolic planners with large language models. The benefits are obvious because symbolic planners are traditionally very reliable and very efficient, both in terms of computation needed and in terms of achieving the ultimate right solution. However, since they work with formal logic, they are really structured and fixed, and they are very expensive to translate to different problems. They lack the reasoning capabilities of large language models. So symbolic planning started from more than 50 years ago in 1971, and it uses concepts including formal logic, heuristics, and graph search to arrive to those decisions. Mostly it is numeric methods. And the paper that we are seeing today was tested on Alfword, which is a text environment for search to meet specific goals with 7 possible actions. So in this environment, we have a variety of objects where we do not know which are there or what actions we need to apply to them to meet the goals. This is a text word, and they use the LLM plus the symbolic planner to arrive to better results. For those of you that know React or even Reflection, you may already know this. I have a couple videos on that if you are interested. And there's a very important concept in symbolic planners, that is world state, and beliefs. Symbolic planner depends on a representation of the environment. And based on that representation, they derive beliefs. Beliefs are predicates that are not known about certain things about the environment. So this may be assumptions or this may be unknowns. And here's an information pipeline that illustrates at a high level how the integration between large language models and symbolic planners work. So symbolic planners use a formal language, a symbolic language. It's similar to a programming language where each operator has a very defined action, while large language models are largely ambiguous, navigate the ambiguity of human language. So here we first see that large language model starts by translating the task in human language to a formal definition by PDDL, and the PDDL, the symbolic program, generates plans, and these plans are executed, and the LLM sees the observations to update the state. So that is at a high level. And here is the pseudocode representation of the same pipeline. We will go through it step by step. It all starts with the domain definition language. This includes the initial state of the environment we are, plus the available actions and the objects that we are aware of. This sets the rules of the environment. Once we have the rule, we receive the dynamic planner receives the goal in human language and is translated by the LLM. This is one of the first use cases of LLM, and we can start to see here that we get the applicability of LLMs. Before, the domain language and the goal generation would need to be manually inputted, and right now we are able to extrapolate and maybe even adapt the same planning mechanism to different problems. Once we have our goal and our domain, including our initial state, we start sampling beliefs. This is, okay, based on our initial state, what do we know about the environment and what we need to know to achieve the goal. For example, if a certain task is to find a tomato in a kitchen, one predicate, one belief is, where is that tomato? And we can even translate that even more specifically, is the tomato in a subset of places, in place A, place B, place C, and we can have those sampling beliefs as unknown. So once we have these unknowns, we generate plans that incorporate our beliefs. And these are multiple plans that all may achieve the goal based on the state of the beliefs. And again, this is very symbolical, very programmatical, extremely efficient. Once we have these plans, we need to select one of those plans. And this is again where the LLM may be used, potentially be used, to, based on reasoning, infer where the plan. For example, if we are searching for the tomato, we will search in the kitchen, not on the fireplace or in the living room. That capabilities may bump in efficiency the use of using large language models over purely symbolic reasoning. That's the second benefit. And once we select the action and execute the action, we observe the results. And again, this is part of a large language model, no translation necessary. We do not need to write a program. We do not need to write an interface that communicates between the environment and the symbolic planning. And we process what we see and update the state of the world and update the beliefs. And we start again, we see the while loop. We start again from sampling beliefs until we achieve the goal. That is, in essence, how we can combine a planning algorithm from symbolic logic to a large language model. And these are the most impressive part, which are the results. Here we see the difference between React and the dynamic planner. First, in efficiency. We are comparing 64% to 96%. But even more impressive is the number of tokens. We go from 10 million tokens to 600. If we simplify it further, we go to 60,000, 67,000. It's a 100 or 1,000x improvement in cost efficiency. Imagine operating this at scale, the savings that you will have. And what is this particular efficiency that they use? They didn't ask the large language model to select the next action. Instead, they use a random action, which impacted in more steps. That's the second table. We go from 13 steps to 15 steps, but we drastically reduce the consumption of tokens. Also, in terms of steps, is quicker. We go from 13 to 18. And in terms of speed, we are also quicker because instead of prompting the LLM so many times, we outsource most of the more complex tasks to the symbolic planner. I hope you can start to see the benefits of this approach. Now, I want to dive deep on this comparison. Maybe some of you are not familiar with React. React stands for reasoning plus action. So we have two types of agents. The first reasons about the task, and the second executes the task. So if we have the task, it's almost like the reasoning part is almost like the plan generation. But instead of generating multiple plans and sampling the beliefs and finding the optimal next action, we only depend on the next action from the large language model, almost magically. And then the action is the part where we are actually using the LLM in the same way. So it's a very simplified way of what we are already doing, but exclusively verbally, exclusively reasoning. Reflection is the second iteration of this. It achieved the same 97% of efficiency in terms of task completion, but it learned from its mistakes. It incorporated verbal reinforcement learning, an extremely powerful technique, but also a very expensive one. On all the occasions that React missed, what it did is restarted the environment and proceeded to learn from its mistakes. So if the first reasoning was wrong, then it said, okay, what did I go wrong? Okay, now I know that I shouldn't search for tomatoes in the living room, which is, again, expensive because first, the only way it can know it fails is after trying 30 or more times. There is no formal representation of the environment that leads to a factual understanding of whether we are right, of whether those actions will lead to the goal or not. We are probabilistic. We are in randomness. We are in chaos, as opposed to the entropy and order of symbolic planners. So pros and cons, we already saw in terms of efficiency, in terms of cost, in terms of speed. We have some cons in terms of adapting the symbolic planner. Also, symbolic planners are not necessarily easy to learn. They are not a widespread technology. It's a very niche technology. So we have that in terms of cons. Yet, I love this phrase that says, LLM's semantic knowledge is leveraged to translate the problem while guiding the search process through instantiation. It pairing semantic knowledge with formal reasoning, an extremely powerful technique, which is at the core of this technology. Some example applications. I want to build up some muscle with this, memory muscle with this, to understand better the technology. The first is in customer service, which is a great application because it incorporates a very well-defined space with a very specific set of actions to a well-defined goal. So when we are resolving a problem, it's not that there could be millions of problems. We may already know what specific parts of the customer is having an issue, what expected experience is not having. Similarly, in terms of actions, there is a well-defined state. Sometimes we even have a guide. This is relatively similar to sales as well. And an extra benefit of this architecture is that first we can learn. So as the agent starts to getting more reps, it starts getting better. It starts understanding, and we can improve our representation of the world and our planning capabilities. But even more importantly is that we can have a two-tier customer support service. So if the first tier by the LLM agent is not met, we can escalate it to a human. So it's a great application, customer service. Second is logistics. And logistics is important because it's already an area where it's used a lot, this type of symbolic planners, because it involves a lot of numerical optimization. We need to optimize where a shipping will go to, from which points, what packages will be delivered, waiting times, etc. However, there's a lot of textual information which we are not incorporating. Maybe it can be related to news, either geopolitical, weather related. It could be related to demand, whether we will need, there's a change in demand. And these capabilities can plan better. Similarly, there's a lot of human involvement during the process, and the LLM agents could automate part of that. So logistics is another great area, which hasn't such a well-defined space, but it allows to apply LLMs to a very numeric space that otherwise will be not possible, especially because logistics may be delicate. So if you ask an LLM to ship a container somewhere and it hallucinates, that would be a very costly problem. Next is project management, and this is my favorite, because project management is, I'm oversimplifying it, but project management is assigning, scheduling, monitoring, unblocking, communicating, and delivering. Those 6 steps is basically maximization problem. I have this set of resources and I have this goal and I need to find the optimal path for it. But there's a very interesting second element in project management that makes it ideal for using LLMs. And that is that we as humans cannot scale beyond a single team. We can only have 12, 15, 20 people at most managing knowledge workers in terms of project managers, because otherwise the information will start to be lost. But a centralized agent can have those scalabilities to incorporate all information and optimize problems around huge teams. We can manage problems centrally by 100,000 people, all working in very specialized tasks. And I'm not saying that managers will go away. Instead, we will shift from an operator perspective to a strategist part. So in this case, instead of supervising the task, we will be focusing our best talent in strategical thinking and the most complex aspects of it. Finally, performance marketing is also a very obvious one, because it requires a lot of creativity and it involves a lot of numerical data. So these type of problems are traditionally where symbolic planners will not shine, because the problem space is too ambiguous, too vague. But using an LLM, we can translate the complexity for a symbolic planner, and we can run thousands of experiments, hundreds of different experiments, both powered by the LLM, but also by the intricate knowledge that the symbolic planner starts to develop. These are some of the most exciting applications, but there might be even more. And this technology is just getting started. We are just laying the foundations of it. I invite you to share which other applications you see where we can pair symbolic planners with large language models. And there's even more. There are some questions that I would like you to share, that I want to share with you for a discussion, to share on the comments, to share perspectives, to learn from each other. First, in this project, they are proposing integrating the LLM in the goal generation, environment observation, maybe action selection. Are these the only steps that it can be? There are a couple other papers that use it in the domain definition language generation. Can we use it, for example, in the plan generation? Again, this is just one integration. I would like to explore different integrations. That's interesting. Second, we notice that there are when there are no longer viable plans. That's one of the problems. So how can we include exploration using LLMs? So maybe some part of our domain definition is wrong, or maybe some part of the goal generation is wrong. How can we use an LLM to explore, validate, not the beliefs, but instead the world state, to find problems where it's failing? Because today, 75% of the errors of this environment were because the goal was translated wrong. So solving that translation problem is very important, but even more important is finding solutions beyond what we already know. And that's where I think exploration will play a big role. Next, and finally, what is the best action selection algorithm? Again, we replace it with one that is random, but can we maybe instead use embeddings for it? Maybe we are not going full scale with, and use that numerical data from the embeddings to insert into the symbolic planner. I hope you can start to see how this is a very rich area for ideas, for initiatives, for research, for creativity. A few more questions. Is the architecture generalizable? Like, is this six-step process that I described, the definition of the language, the generation of the goal, the sampling of beliefs, the generation of the plans, the observation of the environment, and the cycle selection, is this generalizable? Or are there steps that could be different from other problems? Second, what type of problems are ideal for symbolic planning? We saw that in customer service, that problems that have a very well-scoped problem statement and set of actions may be ideal for symbolic reasoning. Or we saw the other opposite in terms of marketing, that are very open-ended problems, but maybe can be translated numerically for optimization with symbolic planners. Maybe there are others, maybe one of those, maybe every problem is ideal for this. Maybe every problem that meets a certain complexity threshold is ideal for this solution. Finally, almost finally, automation generation of PDD. I mentioned there are a couple of papers already exploring this area. How can we use large language models to create the language so that the symbolic planner can fully act in the world while without any human dependence? So we just train, we just say, okay, the LLM, your job is to write a domain definition language for the marketing area. And that would be all. Next, can every problem be represented symbolically? That's a very philosophical question. I'm sure there are already answers in the field. If you are one expert in symbolic reasoning, I would like to hear from you. Share your expertise, share your comments, share your insights. Or if you are not an expert, theorize with me. I wouldn't dare to say something without carefully thinking about it. But if my intuition tells me, my intuition will tell me, yes, every problem is represented symbolically. My experience will tell me, no. The world is far more complex to be simply representing things symbolically. And finally, does the human brain has elements of neurosymbolic planning? This is exciting because once we define our plan in our ventrolateral neocortex, it almost stays fixed. Like we start the execution. There are sometimes when we revisit the plan, but what would happen if we start learning about those human mechanisms, about for which type of problems do we generate a plan? On which type of scenarios do we revisit our plan? If we can grasp that understanding and embed it into our models, they will be far more robust and will be able to handle far more autonomous and handle far more complex problems. That was all. Thank you for watching. I love sharing these big ideas. I love having the opportunity to connect with people that share the same passion for AI than me. If you like the channel, if you like the content, I would really appreciate your support. Your comments, your likes are extremely important, and your subscription. This keeps making the channel sustainable. Thank you. Goodbye.